Okay? The 3D quantification tool for the NPR. But here we'll go for the 4D cardio view, one click.
Our machine is not that high end. We have got 3DQ. So
Yeah,
if
3D, the same.
so if everyone agrees, can we go about with 3DQ tool?
If it is available, yes. Because sometimes it shows up here in the software, but it doesn't work. Let's try 3DQ. See? It doesn't show. Yeah. But it is the exact same concept. You have 4 screens and you manipulate the lines. It is the exact same thing, like in MPR and CT. So 4D cardio view. Any MPR analysis has to start with the time, at which time you need to analyze the mitral valve. So, how to choose the time? I will pause, okay, and then move frame by frame to reach the suitable time I want. If I need to measure the annulus, for example, at the beginning, I need systole, so I will go frame by frame till the mitral valve closes, okay, and this is the highest prolapse. Okay, now I start to see this. If I'm doing this on my own, I will just use the buttons right and left to see the suitable time. But because we are in a workshop, we need to be at the same frame. So there is another way of moving frame by frame. If you look down here, you see an ECG signal, green one. Can you see that? Above this ECG signal, you see a green arrow. Catch and hold this green arrow and move it from side to side, and then you'll be able to move in a frame by frame way. It tells you the numbers of the frames now. So for example here we'll go for frame 4 because it is showing the peak of the prolapse. So choose frame 4 please. Okay, from down. Everybody's there? Okay. Now look at this data set here. You can see it is cropped already, half LV. Right? I need to see the whole mitral valve. I need to remove the cropping. Look up here, there is a scissor signal here. Click the scissor and then you will deactivate the cropping. If you click the scissor again, it will crop the data set. Okay? Good. Now I need to flip the image, the 3D, to see it. Look at me first. Do not touch the 3D image. Go for the dark area here, click and hold and then flip it like that. Do not touch the 3D image itself. Okay? In my data set, I can see the aortic valve down and mitral valve up. This is not the usual surgical view. So we need to flip it upwards. How to do this? Look at my screen again. If you hover over it, you will see like a curved arrow here. Just click it and then do this till you have the mitral valve upwards. That one, that icon here. That's a more or less surgical view now. What the? How did you get there? Mitral annulus. Do you remember the tool for automated quantification? The blue line was just above the annulus. Do you remember that? So we need to bring the blue line just above the annulus, like that. And that one also above the annulus. And the purple line just in the middle of the annulus also. Okay? Now, the blue line is in the middle but not that parallel. You can see the aortic hinge point is lower and the posterior point is higher. So we need to tilt this line. Okay? In the automated software that was done automatically for you, but now we need to do it manually. Okay? Okay, now I've done this because the blue line here is just above the annulus and parallel. The blue line here is just above the annulus and parallel. In the blue frame down, I see the short axis view of the annulus. Agreed? Good. Shall I measure here? No. No. Why? We have seen from the model that the mitral annulus is saddle shaped, right? It is not flat structure. So you never measure the mitral annulus in a flat way like this, because this is as if you are saying the mitral annulus is flat. But what to do? I use this only for orientation. I need the purple line in the middle of the annulus, the anteroposterior dimension, and the yellow line in the major dimension of the annulus. So how to do this? You tilt the purple line like this. Now it is in the middle of mitral annulus, and I will take the yellow line down here in the major dimension of the annulus. Okay, and where to measure? I will measure up. I will not measure down. Okay, Now I measure two dimensions for the annulus, the anteroposterior dimension and the intercommercial dimension. Okay? How to measure? You see this ruler sign, measurement, click it, and then click the distance, then you click from hinge point to another hinge point, like that, and then click distance again, and from the aortic hinge point to the posterior hinge point. This is the annulus dimensions. You never express annulus dimension in one dimension, because the annulus is not a circle, right? So at least you report two numbers, the anteroposterior dimension and the intercommercial dimension. So in my practice, I usually report the annulus as, for example, like 35 by 40 millimeters. And if I need to do like add extra information, 35 between two brackets AP, anteroposterior, and then 40 IC, intercommercial. Okay? But the practice of expressing the annulus in one dimension is totally wrong. This is as if you are saying it's a circle, which is not, right? Okay. What else to measure now for the clip, for example? Now I'm cutting in the middle of the annulus here, right? The verbal line. This verbal line here is cutting at the middle of the mitral annulus. That means which scallops are seen here? A2, B2, right? Here I'm cutting in the middle, so below the aortic valve, this is A2 scallop, this is B2 scallop. If I'm cutting here near the septum, it will be A3, B3. If I'm cutting here, that will be A1 and 1, right? Good. So I know now this is A2 and this is B2. Agree? If I pull this line here and I put it here, see where is the verbal line now? It is laterally. So this is 1 and 1. If I put it here, this is medial. This is A3 and B3. So I can measure anything I want now, millimeter by millimeter. For example, the pathology here is an A2, B2. I will make this large, click it, click the small box, it will be large. Okay? Then I will measure it. This software is giving me a very good opportunity to measure even the curved distance. So A2 here is not curved, so I can use the straight distance, like that, more or less, but that one is curved. On the machine, if you need to do this, you need to do this in pieces and then add them together. But here, use the curved length. Curve, and then stop at any point, and then you just click, 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 and then double click. It will give you the length of the curved leaf. Okay? Now you have A2 and you have B2, and then you can sweep the whole valve and measure anything you want. Okay?
And in this MP, how to go about the valve area calculation? Because these are the parameters we need: posterior leaflet length, mitral valve
valve
area.
area calculation. You remember when I told you the first step in any MPR analysis is to assess, to check the time first?
Yes.
Okay, the valve area should be measured in systole or diastole? Diastole. So this is not in this frame. Here we are measuring the annulus, we are measuring the leaflet length, and we can measure also for the mitral valve prolapse something called the flail gap and flail width, right? If the valve is stented functional, we measure the coaptation length and coaptation depth is something else. So here we are still doing the systolic measurements. We'll come to the mitral valve area later. What else? If you click this box here, you will go back to the 4 screens. I need to measure 2 more dimensions. If the patient has prolapse or flail, we need to measure something called flail gap and flail width.
Yes.
Flail gap, easily done here. If I remove all the measurements here, this is the flail gap. This is very minute, like distance. Just the distance between the 2 tips. Okay? That is like 1 millimeter. That shouldn't exceed 10 millimeters classically. Now with the longer clips, we can overcome this. But let's say if I just simply measure this distance here, and then I will call it the flail gap, the gap between the 2 leaflets. Okay? The other measurement, which sometimes confuses some people, is called the flail width. The flail width, if I increase this view here, see this is the flail width. How much of the annulus is occupied by flail, not the longitudinal gap between the 2 leaflets. This is the flail width from here to here. And on this software, I can do this. From here to here. This is the flail width. Okay? On the 3D itself, I can do this.
Is it okay to do on 3D?
For this one, yes. But I'm against measuring anything in 3D itself. But for this, you can just get the gap. Or Alternatively, you can do this. See that? That's the flail segment, right? If I put this yellow line and put it on the top of the flail segment here, see what happened on that screen? You see that? Here I was in the middle, I didn't see it, but now I put the yellow line on the dome of the collapsed segment, and then you measure from here to here, this is the flail width. That's another way of doing it in the MPI. Okay? Good. What about the mitral valve area? Now I need diastolic frame. Agree? So I'll move frame by frame till the mitral valve opens. For example here. Okay? Where I should put my blue line? At the tips. So I'll bring that down at the tips of the mitral valve, and then I have the mitral valve area, and I can trace it by the area, not by the distance now. So I'll make that large, and then I'll just choose the area, and then you have to click every time you need to change the direction, and then the last one will just fuse automatically to give you the area of the mitral valve. That's a manual way of analyzing the whole mitral valve, whether for surgery or for HLG. Okay? Good. So we have.
Dr. Hani, one question.
Yes, please.
This mitral apparatus is funnel shaped.
Mm.
At what point are we supposed to measure the
Tips.
area, the tips?
The tips of the mitral
Because
valve.
a lot of time when it is opening in the diastole, then the cordies also get attached, appears to be
It's mainly
attached.
in mitral stenosis.
Yes.
Yeah, in mitral stenosis, yes.
So because
But-
when if this image also, if you see one leaflet is going down, and
Yeah,
the other
but
one,
remember
whether it's a
something-
dropout or
That this is a
Yes.
subvalvular apparatus
Yes.
here. But remember that subvalvular apparatus in cases where there is no stenosis, it is just cords. It doesn't cause real funnel shaped orifice of the
Yes.
mitral valve. But in mitral stenosis, yes, it goes down. In that case, you go down as long as you see a full circle, just go for the full circle. Okay?
Okay.
So if it is a circle complete, you go for it. Otherwise, if it is like a band from here, but there is nothing here, this is not an orifice. Okay? Okay, X. Don't save any bookmarks. Exit.